We are looking at elementary statistics, practice test 2, module 2, chapter 5, discrete probability distribution. We are given a table which represents X number of gears, 0, 1, 2, 3, and P of X is the probability, okay, of 3 bits. Does it describe a probability distribution? What is the random variable? What are its possible values and or its value numerical? Is this describing a probability? For this to be a probability, this must be numerical. It is. The probability in each case must be between 0 and 1. It is. And they must add up to 1. Those are the main things that you want to be careful. So the variable x, which is the number of gears, okay, 0, 1, 2, 3, is a numerical random variable. And they are associated with probabilities, okay. So the next one is that the summation is 1, so each one, and of course, each value is between 0. There are really different criteria. These are the main criteria. Number 1, make sure that each one is between 0 and 1. Can it be 0? Yes. Can it be 1? Yes. But it can't go beyond. Number 2, make sure they add up to 1. By the way, this is where I discussed that you may end up with the situation where the sum is not exactly equal to 1, but it's extremely close due to round-off error. I'm going to repeat because this is important. If this is 1.000000001, that's okay because it's just due to round-off error. Or if it's 0.9999, many nines. But if it's 0.99, that may not be good enough. Or if it's 1.1, it's not good enough. Okay. And of course, the variable x, which is the number of gears in 3 bits, what can it be? 0, 1, 2, 3. They are all numerical random variables. Okay. And they're associated with probability. So that explains that. In a game, you pay 60 cents to select a 4-digit number. If you win by selecting the 4-digit number, you collect $3,000. This is what I mean when I said, you know, you play lotto versus a blackjack and the concept of a payoff. So when you pay 60 cents, your 60 cents is gone. You bought it, gone. Whether you win or lose, it makes no difference. The 60 cents is gone. And that's the idea. If we win, we collect $3,000. How many different selections are possible? It's important to know that we are looking at 4 digits. There is no restrictions given. Remember, the digits is from 0 to 9. That means 10 numbers. So there are 4 spots. That's important to see. There are 4 spots. Let me just, that means we have 1, 2, 3, 4 spots. And that means 10 to the power of 4. And that means 10,000. And at the top, by the way, I have the formulas. Mu is summation of x p of x. Sigma squared is summation of x to p of x minus mu squared. This is a second method to write that. And so let's do that. N, the number of digits is 10. Why is that? Because we go from 0 to 9. There are 10 possible numbers in 4 places. We have 10 to the power of 4 or 10,000 ways to pick. What is the probability of winning? There's only one possibility of winning $3,000, so 1 out of 10,000. So what if we win? If we win, what is our net profit? Well, we win $3,000, but we paid 60 cents, so minus 60 cents. And that's important to understand. The net profit is the money that we gain minus the investment. Granted, the investment 0.6 compared to 3,000 is peanuts, yet you have to write that. Now write the probability distribution of net profit if you win. The probability distribution, it's simply putting the x as well as p of x. That's it. So we are looking at part D. The winner, 3,000. There will be how many? 1 winner. And the rest, 10,000 minus 1, 9,999 we lose. And the total is 10,000. Now, net gain for the winner is this amount. We just calculated, right? But what about the rest? The rest would be 60 cents with a negative sign. I can't emphasize the importance of writing this properly, including the sign, negative 0.6. So what is the probability? What is the probability of X? For this one is 1 out of 10,000. For this one is the rest, 1 minus that. So 9,999 over 10,000. And as always, they must add up. These two must add up to 1, and they do. This is it for part D. It says, write the probability distribution. This is the probability distribution, okay? X is numerical, okay? X is a number. Probability is between 0 and 1. They add up to 1 or 100%. So everything that we discussed in the previous example, it checks. Now we want to find the expected value, and more importantly, what does it mean? So to find the expected value, okay, mu is summation of x px. So let's multiply x by p of x. Let's multiply this column by this column, this number by this number, this number by this number. Now this one is for the sake of calculating the variance. It hasn't been asked, but this is what really we want. I figure it's not a bad idea to see what happens here. So the product of these two gives us this number. The product of these two gives us this number. Now, this is extremely important. But by the way, how do we come up with that x squared p of x? Square this number. It's almost 3,000. It's not 2,999.40. Square it times 0.0001. You get this one. Square this number, which becomes positive, by the way, times this number. And you write it here. That's the summation of x squared p of x, okay? We got to get there. That is really not what the question is asking us, but I thought at least you have seen the calculation here. Now, summation of x p of x is mu, and it's negative 0.3. And this is extremely important to understand. Mu is this amount, whereas sigma squared is this amount minus mu squared, and sigma is the square root of that, by the way, which is sigma squared is the variance, and sigma is the standard deviation. Well, we can calculate that, but really, even if we don't, this really is telling everyone, and that's, okay, the interpretation. Everyone who plays on the average gains this much. How much? Negative 0.3. That means what? Everybody loses 30 cents on the average. Everyone loses 30 cents on the average. So mu is negative 0.3. Sigma is this formula. Look at this formula, put it under the radical. You have this one minus mu squared. You're going to minus mu squared. You calculate that. And they didn't ask for this one. I just added. Okay, it's not. What matters is the first part. On average, a player, all players, including the one who wins, all players, okay, they lose. So a player loses how much? 30 cents on average. That means per ticket. What does it really mean? I want to make sure we understand the meaning of this and the importance and the power of this statement. And that is, for every ticket that they sell, they collect 30 cents from the people. So the company offering this is, on the average, collecting 30 cents from each player. Every ticket brings them some money. How much? 30 cents. And that's important for everybody to know. A pharmaceutical company receives large shipments of aspirin tablets. This is called the concept of quality control. The acceptance sampling plan is to randomly select and test 24 tablets. So we have a huge shipment, and we randomly select 24 of them. The entire shipment is accepted if at most 2 tablets do not meet the required specs. If a particular shipment of thousands of aspirin tablets actually has a 5% rate of defects, what is the probability that this whole shipment will be accepted? Okay, so let's just quickly recap what's happening. This is a quality control. They receive a huge shipment. They can't check every tablet. So what do? They have decided that if they randomly pick 24, and I can't emphasize the importance of randomly, because otherwise it defeats the purpose of doing this test. You randomly pick 24, and if two of them at most is no good, you say the whole shipment is out and they have to take it back. That's the concept they have come up with. And they know there's a 5% rate of defect. They want to calculate that. So we are going with BD, binomial distribution. And in short, binomial distribution, really you have two outcomes. Okay, N is the number of trials. And the two outcomes, good, bad, tails, heads, okay, defect, or it has no defect, things of that nature. Again, the formula is in the formula sheet, P of x equals n factorial over n minus x factorial times x factorial, P to the power of x, Q to the power of n minus x. Mu is np and sigma is square root of npq. Those are the formulas that you need. So this is a binomial distribution. So if you're claiming this is a binomial distribution, you always need to give two things. What is your n? What is your p? N in this case is 24, p is 5% or 0.05. Remember, p refers to the probability of success. Success doesn't necessarily mean something positive. That's important to know. So if we want to go with this formula, we are going to replace the p with 0.05. We're going to replace the n with 24. And everybody remembers that q is 1 minus p, or 0.95. By the way, these are the probability distribution properties: n identical or fixed number of trials, each repetition of the experiment. Each has only two categories of outcomes. Probability is constant, and they are independent trials. So with that being the case, here's the formula that we are going to use, where p is 0.05, q is 1 minus that 0.95, and that is the formula we're going to use by replacing the n with 24, replacing the p with 0.05, and q with this. And now what happens? Let's go back and read. The entire shipment is accepted if at most two tablets do not meet. So probability of at most two tablets, that means probability of x less than or equal to 2. So when x is 0, it's you plug in 0 instead of x you calculated. When it's 1, you plug in, you calculated. When it's 2, you plug in, you calculated. So you want the probability of x equals 0 plus the probability of x equals 1 plus the probability of x equals 2. And I'm assuming everybody can do that. By the way, I put here x equals 0, and then I didn't put x here for short: probability of 1, probability of 2. And they add up to 0.884, which of course means 88.4%. They didn't ask for a percent. That's good enough. Now, if you want to go with this formula, you have to plug in 0 calculated, 1 calculated, 2 calculated, add them up. You can also use, after you understand the concept, after you write it's a binomial distribution, after you write this formula, then you can use this simple, and it's in posted, okay, in the formula sheet. Also, it's given in the PowerPoints. So second variable is binomial PDF, enter NPX. And if you enter NP only, that gives the probability from 0 to n. And if you're using binomial CDF, it gives the sum of it. So take a look at what we do. We put binomial CDF. The number is 24, probability is 0.05. When we put x equals 2, that means from 0 to 2. It calculates, and notice the answer, of course, with a lot more decimals. So we have the same answer. It is known that 90% of managers of all companies suffer from job-related stress. What is the probability that in a sample of 10 managers, exactly 8 suffer from job-related stress, so on and so on? So the very first thing you need to recognize what type of a distribution we have, and this is a binomial distribution. Why is that? There are only two outcomes. Either they have stress or they don't. So what is n? We are looking at n equals 10. What is p? We are looking at p equals 0.9. So it's a binomial distribution, n is 10, p equals 0.9. Again, p doesn't have to represent something positive. In this case, if P is 0.9, that means Q is 1 minus that. And for this formula, we're going to replace the N with 10, okay, and P with 0.9 and Q 1 minus 0.9, which is 0.1. So P is 0.9, Q is 0.1, plug it in. So this is your formula now. Probability of X is 10 factorial over 10 minus X factorial times X factorial times, now P is replaced with 0.9, Q with 0.9. Practically you're done. So for part A, all you have to do, replace the X with 8. So probability of 8, replace the X with 8. At most 2 suffer from job-related stress. At most 2. The same as the previous page, X is less than or equal to 2. By the way, if you go with the TI calculator, you get to the answer. Notice binomial PDF 10.98. Here's the answer. At most 2, you need to calculate the 0, 1, and 2 and add them up. Okay, 0, 1, 2. How do you do that? In this formula, replace the X with 0, replace the X with 1, replace the X with 2, add them up, and it's almost 0. But notice I put a lot of decimals. I want to make a point. It is not 0. It's extremely close to 0. And you can calculate it. Again, I'm showing you one by one calculation. You don't have to do that. I'm showing you in case you wanted to do it by hand. What's important for you is, again, you want to write this for your reader. You want to write this for your reader. You want to write this for your reader, and then you can put the answer, okay? Because you're telling them, you know it's a binomial distribution, you know what's N, you know what's P, you know how to calculate the Q, all of the above. And you know what to do, and at the end, you can use a calculator now. Just as before, just CDF 10.9, it's binomial CDF. And when you plug in, you get this number. Now, it's important to know this is given in scientific notation, and sadly some students don't know scientific notation, so it's important that you recognize when it's a scientific notation how to deal with that. Okay, so that means 10 to the power of -7. So you want to pay attention to that and come up with the proper answer accordingly. Next, at least 3 suffer. That means probability of X larger than or equal to 3. And that means 3 all the way to 10. That's the meaning of it. Again, I'm writing the meaning. Probability of X larger than or equal to 3 means probability of 3, 4, so on and so forth, because that's the meaning of X larger than or equal to 3. However, if you look at part B, probability of X less than or equal to 2, I hope you realize there are complementary events. In other words, probability of, take a look at this, probability of X larger than or equal to 3 is the same as 1 minus probability of X less than or equal to 2. They are the same. Instead of calculating from 3 to N, and by the way, N happened to be 10, it's not a big deal, but what about N being 300? You definitely don't want to calculate that. So instead, you calculate the ones before that and you subtract it from 1, because the total probability is 1. So this is the complementary event you're going to use. And when we do that, it's 1 minus the previous one, which is very close to 1. Again, the numbers are a little bit off. That's why I chose to go with many decimals. So having said that, what is the next part? We want to find the expected value. Well, to find the expected value, mu or E of X is N times P. Find the standard deviation, sigma is square root of NPQ. So we multiply this by Q and we take a root. So this is sigma squared. Now take a root. Very straightforward. All of these formulas in your formula sheet you should be comfortable with. Finally, would it be unusual to claim that at most 7 managers from this sample suffer from job-related stress? All you have to do, just go with mu plus minus 2 sigma. I hope you remember this, the empirical rule, mu plus minus 2 sigma, okay? The range rule of thumb. So mu is 9 minus 2 times this number, and then mu is minus, this is number 9, add and subtract, and between 7.1 and 10.89. Is this number going back to this number? In between, if it is, usual. If it's not, it's unusual. Although it's extremely close, but it is not in between. This means it's not an element of, this is in set theory, not an element of. It's not in between, therefore unusual. Okay, not in between, therefore unusual. Find the probability of couple having at least one girl among 3 children. The probability, the assumption in biology is that the probability is the same, 50% or 1/2 for both cases. Okay, so we want the probability of at least one is 1 minus the probability of a none. Noticing this one, so 1 minus none. When we say having at least one, none, that means all of them are what? The other gender. All of them are boys. Okay, 1/2. And because the probability is 1/2, and we are assuming independency, by the way, so 1/2 to the 3rd power, so 1 minus that, so the probability is 7 out of 8. You can also do the tree diagram to see that. By the tree diagram, I mean you put the first one, let's say B and G, and then you finish it off. Here's the second method using the binomial distribution, where we have 3 children, n is 3 and p is 0.5. Now, at least 1. That means x is larger than or equal to 1. Now, p happened to be 0.5, so is q, 1 minus that. We want x larger than or equal to 1. That means 1, 2, 3. And so you want the probability of 1 plus the probability of 2 plus the probability of 3 using a binomial distribution, where n is 3, p is 0.5, so is q. You can plug in 1, 2, 3 and calculate and add them up, or just it's easier to go with the complementary event because it's easier to calculate only one of them, plug in 0, evaluate, and 1 minus that. So this is the formula. Okay, as I mentioned, n is 3, p 0.5, q is 0.5. By the way, they add up to 0.5 to the 3rd power because they are identical. The base is the same. And now just plug in 0, subtract from 1, and that gives you the same answer. Whether you go with this method or the other method makes no difference. If an alarm clock has a 0.9 probability of working on any given morning, what is the probability that it will not work? What is the probability that 2 such alarm clocks will not work? What is the probability of being awakened if you have 2 such alarm clocks? The assumption is if it works, you wake up, okay? So what is the probability that it will not work? If the probability of working is 0.9, the probability of not working is the complementary event, and it's 1 minus that. So there's a 90% chance it works. There's a 10% chance it will not work. What is the probability that 2 such alarm clocks will not work? We are assuming independency. There is no reason to assume dependency unless one condition happens, and that is they are plugged into the same power outlet and somehow power goes out. That's the only time that then it will be they will be dependent. Other than that, independency. And so you follow that probability of W1 is the first one working, and W1 not, probability of an alarm not working. Okay. What is the probability that 2 such alarm clocks will not work? It's very simple. They are independent. Each one has a 10% chance, so 0.1 times 0.1. If we want to write it properly, probability of W1 not intersection W2 not, okay, of the first and second alarm not working, and we have to multiply them because we are assuming independency. So 0.1 times 0.1 is the answer. Again, as far as explaining it with the formulas, that really makes a difference. So there's a 1% chance that 2 such alarm clocks will not work. The idea is the idea of quality control. To be on the safe side, if you have 2 alarm clocks, the probability of 10% not working is horrible here. Going to 2, it takes it down to 1%. Imagine if you go to the third one, then you multiply by another 0.1 and it goes to 0.0011, 1 out of 1,000. And that's the idea of the quality control. They use that for example, jet engines also to make sure passengers get home safe. So the engines work independently. What is the probability of being awakened if you have 2 such alarm clocks? There's a 1% chance they both fail, so the assumption is 99% that it won't, and therefore there's a 99% chance we wake up. So this is method 1. 1 minus part B gives us 0.99, so there's a 99% chance. Here's the second method. We can use the addition method. Probability of A union B is probability of A plus probability of B minus probability of A intersection B. And remember, in this case, awakening, that means if it's working. So probability of working is important to us, which is 0.9. So each one is 0.9 in essence. Okay, so we are looking at probability of W1 union W2. Okay, so we are going to replace each one with 0.9. So we get 0.9 plus 0.9 minus the product 0.9 times 0.9. Again, the reason we multiply because of independency, and that gives us the answer the same as before. Finally, the third method, you can use the binomial method distribution. There are 2 alarm clocks, n is 2. The probability of working is 0.9. Here's the probability that we are going to use, and we are going to replace the n with 2, p with 0.9, and q with 1 minus that, or 0.1. Now, we want the probability of what? X larger than or equal to 1. As long as one of them works, we wake up. So probability of X larger than or equal to 1. That means probability of X equals 1 plus probability of X equals 2. Instead, 1 minus probability of 0. So replace the X with 0, calculate it, subtract from 1. That would be a tad faster. And when you do that, you get absolutely the same answer. So there are 3 different methods to solve this question.